Hello engineers, welcome back. In this video, we're going to look at another lead code question to practice backtracking framework. Okay, I hope you're ready. Let's get started. So this is the question we're going to look at today. It is called combinations. So let's try to understand the question and then we'll see how to apply the framework. So given two integers n and k, return all possible combinations of k numbers chosen from the range 1 to n. You may return the answer in any order. So if n equal to 4 and k equal to 2, we need to return this kind of output. Okay, let's see how we can make them. So n equal to 4, k equal to 2. So this is essentially saying you have access to 4 numbers, 1, 2, 3, 4. And with these 4 numbers, we need to make combinations of size 2. So our size is 2. And we can fill the first position and second position using these numbers. So if I choose 1 as my first position, I can make combination of 1 comma 2, 1 comma 3 and 1 comma 4. If I start with 2, I can make 2 comma 3 and 2 comma 4. If I start with 3, I can make 3 comma 4. I cannot make 2 comma 1 because 1 comma 2 is already made. This will be a duplicate, as you can see here. Note that combinations are ordered. 1 comma 2 and 2 comma 1 are considered to be the same combination. So we don't need to redo that. Similarly, I cannot do, let's say, 3 comma 2 because 2 comma 3 is already there. So these are invalid cases. So I only need to return these ones. Okay. So let's see how we can approach this using backtracking, right? So firstly, we know that we have two spots to fill, right? And to fill the first spot, we have a choice. We can start with 1, 2, 3 or 4, right? And whenever we have a choice, we know that we can directly use recursion. So we start with an empty set and then we have a choice to make the first move. So let's say I'm starting with 1 dash. From here again I have a choice. So I can make 1 comma 2, I can make 1 comma 3, I can make 1 comma 4. And if I start with 2 comma dash, I can make 2 comma 3 and I can make 2 comma 4. If I start with 3 dash, I can make only 3 comma 4. The rest of them will remain as invalid, right? I can choose to start with 4, but whatever combination I start with 4 are already made. So 4 comma 1 is same as 1 comma 4, 4 comma 2 is same as 2 comma 4, and 4 comma 3 is same as 3 comma 4. So this whole tree is invalid. Okay. So this is the recursion. So as you can see, we are going down one path, coming back, emptying this set, going down another path, filling this and coming back and emptying it and going down the third path. So this is the classic case of our backtracking. So what is the framework? We make a move, we call recursion, we undo the move and call recursion again. So this is the framework, right? So let's try to apply it. Let's directly code it and then we will trace our code. Okay. So let's make a new function. Let's call it backtrack. We will take n as it is. We will take k as it is. We will need a current vector, which will be vector of int by address. We will need a result vector, which will be vector of int by address. We will need one pointer to go down the tree and another pointer to go down the breadth, to explore the breadth. So these are my inputs. So let's pass them. So we have a current we have a result. We can pass both of them to our backtrack function. Let's see the order: n, k, current, result, and we will start with 0 for our depth, and we will start with 1 for our breadth. We will use the next pointer to add to our subset or the combination, right? So whatever is inside the result after all this will be our answer. So let's see what is our base case. So as we go down this tree, we have hit our base case, right? So the depth is defined by the value k, because if we have two choices to fill, we need to explore the depth of two levels. So when we reach the depth of 2, we have explored our options for the second position, so we can return from there. So the base case is if index equal to k, can return, but before returning, we will add whatever is in current to result. That's it. And we also need to take care of breadth, right? There is another pointer which is taking care of breadth. So this, if next goes beyond n, then we will return. Why? Because we are using next, right? We are starting next with 1, and 1 can go up to 1, 2, 2, 3, and 4. So we need to use next up to 4, and n is 4. But if it goes beyond 4, we don't need it. So that's where we return. So these are my conditions to stop the recursion. And then we will do our move. Move is current dot pushback next. We are adding the next pointer. Next, you can say index. Next is carrying the value 1. So we are making the first move. We are adding 1 to our subset. And then we call recursion again. This is backtrack nk current result. And we will do index plus 1 to go down the tree, and next plus 1 to go left to right. And then we undo the move. Undo is easy. Current dot pop back, undo the latest move, and then we do redo of the whole thing. Here we don't need to change the index because we need to go breadth. And that's it. That's the whole code, I think. Let's see. Yeah, it is accepted. So our solution is accepted. Now let's try to trace the whole tree so that we can trace our solution. So we are here. So our start position is I equal to 0, next equal to 1, and we have an empty box in current. So we make the first move. We are adding 1 to this. So let's add 1, and then we will start calling recursion. So when we are calling recursion, we are doing index plus 1, next plus 1. So I equal to 1, next equal to 2. Now we are back to this place. We will add this again, 1 comma 2. We will call recursion again, I equal to 2, next equal to 3, but this is our base case, I equal to 2. So index is here, k is 2, so we have hit our base case. So we will add it to our result and return. So we have added it, and now we return. So what was here? Here the state was 1 comma 2. So we added this and we return. Now we do a pop. Whenever we return, we undo, right? Undo is pop, and then redo. Undo is pop. We have popped it, and then now we can do redo. This is the current state. For redo, index will remain as it is. Next will go forward. Next is 3. Now I have called recursion, so I will add 1 comma 3 to my current set, and then we will call recursion again. Now I will become 2. Next will become 4, but this is our base case. I is 2, so we will add 1 comma 3 to our result and return. So we return, and then we do a pop. This is our current state, and then we do the right tree. In the right tree, index remains as it is. Next will become 4, so we will add 4 to our subset 1 comma 4. So we'll call recursion again. I will become 2. Next will become 5. So as you can see, for the left tree we are doing index plus 1, next plus 1. For the right tree we are doing index and next plus 1. Okay, that's the only change. So this is our base case again, I equal to 2. So we can add 1 comma 4 to our result and return. So we have written here. So when we return, we do a pop. So let's do a pop, and we go down the right tree. For the right tree, index remains as it is. Next will become 5, and this is a dead end. Now we have hit the second condition for our tree. If next is greater than n, so next is 5. 5 is greater than 4, so this is a dead end. We can directly return. So let's return. So this right tree is done. This right tree is done. This right tree is done. And we are coming back here. So this is also done. Now we can do a pop. Let's do a pop. And now we'll do the right tree of this guy. We'll make a new move. So our exploration with 1 is over. Now we will explore with 2. So this is the right tree of this guy. So for right tree, as we said, I will remain same. Only next will move forward. Next is 2 now. Now we have called recursion. So this is an empty box. Now we can fill it with 2. 2 dash. Right? And then the whole cycle repeats again. So let's see. For the left tree, I plus 1, next plus 1, and call recursion again. Now we can add 2 to, we can add next to this set. So it is 2 comma 3. We will call left subtree on this, I equal to 2, next equal to 4. This is our base case. So we can add this to our list and return. So this is the return. And when we return, we do a pop. This is the pop. And then we call the right tree. Right tree will have index as it is, I equal to 1. But next will go forward. Next will become 4. Now I can add 4 to this, 2 comma 4. And I will call the left subtree. And for left subtree, I plus 1, next plus 1. So I will be 2. Next will become 5. But this is our base case. So we will add 2 comma 4 to our result and return. Done. We will call the right tree now. Right tree has I as it is. Next will become 5, and this is a dead end, and we can directly return now. Return, return, return. So our exploration with 2 is also done. Return, return, return. Now we can pop it. Pop. And we have an empty set. So now we can do right tree of this guy. So I will remain as it is. Next will become 3 now. And then we will add 3 to our set, 3 dash. And then we repeat the process. I plus 1, next plus 1. We will add 4 to our set, We will call left subtree I equal to 2, next equal to 5, but this is our base case. So we will add this to our result and return. So we have added to our base case and return. Let's do the right tree. So right tree is I equal to 2 and sorry, I remains as it is. This is right tree and next will become 5. So this is a dead end. So we return from here. So we return from here, we return from here, and we do a pop. So this is the pop. And then we can do right subtree of this guy. For right subtree, I remains as it is. Next will become 4 and we have an empty set. So 4 gets added here. We do the left tree. I will become 1. Next will become 5 and this is a dead end. So return. And we do the right tree, last piece. For the right tree, I will remain as it is. Next will become next plus 1. So next is 5. Again, this is a dead end. So nothing to do here. So we can directly return, 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 and return, and return. Okay. So this is the full trace of our tree, of our solution. So I hope you found the solution useful. Do practice and trace out your solution so that it is more clear. As you do more problems, you will have more confidence on this approach. So if you have any questions, you can definitely ask me in the questions in the comments. And thank you so much for watching, guys. Don't forget to leave a like and don't forget to subscribe to the channel and bookmark the playlist so that you don't miss out on any future videos. Thank you so much for watching. I will see you in the next one. Cheers.